Okay, in this handout, H8C, sinusoidal transformations and sinusoidal regression, we're going to talk about the period, we're going to talk about amplitude, we're going to talk about shifting left and right, and we're going to talk about principal axis movement. But we're also going to show calculator steps on sinusoidal regression. Okay. But first things first. So we've got this general formula which we're going to discover which variables, the A, B, C, and D, affect how they affect our sine wave and cosine wave. So we used our graphing discrete calculator to graph sine x and sine 2x. I set my window here to 2 pi. So window, let's change that to 2 pi. Enter. And so I'm going to hit y equals, clear that. I'm going to hit sine x, x, graph. And we already know what that looks like, right? So now we're also going to graph sine 2x. What happens? Sine 2x. And notice the 2 is inside the parentheses there. Let's graph that. And you can see that it's going to do 2 graphs in the space of the sine wave. In between 0 and 2 pi, it's going to have 2 periods. Okay, the period from here to here, the length of there is pi. The length from here to here is 2 pi. And the B value is this number here. Okay, there was no number in front of the x, so my B value was 1. Okay. Our next example here, we're going to do sine x 1/2 x. Let's change that to 0.5 x. And so this second part right here is the 1/2 x. So from 0 to 2 pi, it just does half of the curve. So I have to extend my window to 4 pi. 4 pi. And I'm going to delete this sine x. So we're just going to see the sine 1/2 x graph. And so if this is set from 0 to 4 pi, we know we get 1 full period between 0 to 4 pi. My B value is 1/2, and the period is 4 pi. Okay, so sine 1/3 x, so my B value is 1/3, and when we graph this on the calculator, we know that it's going to be, the period is going to be 6 pi over 3. So from our knowledge of transformations, and that's chapter 6 of the HL book, but we did this in SL as well. The B value changes the width of the period of the graph, and so we realize we're going to figure out that the period is equal to 2 pi over B. So when my B was 2, I could put that into 2 pi over 2, and we knew the period was pi. If the B value was 4, then I know it would do the whole circle in pi over 2. So the B value either shrinks or stretches the period, and it's stretched horizontally. Okay, so now the A value is going to stretch the graph vertically, and that's going to affect something called the amplitude. So if I've got, so I need to change my window here. I'm just going to do all of these in 2 pi for the x max, and the y minimum I'm going to make -3, and the y maximum I'm going to make 3. Okay, so now I go back to y equals, and I'm going to clear this, and I type in 2 sine x, and I graph that, and what happens here is the amplitude, this 2 value, is going to make this go up to 2 and down to 2. Okay, and so my amplitude is 2. Okay, so if I've got a 3 here, then my amplitude is 3. Okay, and same thing here. If I've got a 1/2 here, the amplitude is 1/2. And notice it doesn't go up that high, it doesn't go down that low. And then if I've got a negative sign here, it's instead of going up and then down and then back up, it's going to go down. It basically the amplitude is still 1, but it's a reflection on the x-axis. Okay, so now we're going to talk about how the A value changes the graph. So so this is the A value. So when they're talking about the A value, they're saying y equals A sine B x minus c plus d. Okay, so the A value changes the amplitude. Okay, now we've got some new graphs here, and we've got the D value, and that changes the principal axis, as you can see. So the D value shifts the principal axis up and down. Now, this is something we did not do in SL, and that's if I've got a horizontal shift. The D value did a vertical shift up and down of the graph. Here we've got a horizontal shift, so I graphed sine x in yellow here. We know it starts at 1, goes up, down, ends at 2 pi. Now, sine x of pi over 2, let's pretend I've got, if x is 0, I would have sine of pi over 2. So sine of pi over 2 is going to start off at 1. So we're going to start here at 1. If x is pi over 2, I'm going to have sine of pi over 2 plus pi over 2, which is 1, which is pi. So if I go to sine of pi, I'm going to be at 0. So now I'm at 0. And then if I go to pi, if I put in pi here, I have pi plus pi over 2. So pi plus pi over 2 is 3 pi over 2. So sine of 3 pi over 2 is -1. So now I've got this point here at -1 for my blue graph. And as you can see, it is it basically shifted the graph to the left. this shifted the graph to the left. Okay. And we do the same thing here, and I've got sine. So if x was 0, I would be at negative pi over 2. So if I go to my unit circle, negative pi over 2, the y value is negative 1. So I'm going to start here at negative 1. Okay. When x is pi over 2, I've got sine of pi over 2 minus pi over 2. So this is sine of 0. And sine of 0 degrees is 0. So you can see, you go through that whole process. Sine of pi, well, pi minus pi over 2 is going to be sine of pi over 2, which is 1. So when you go through that whole process, you see that this graph here has shifted to the right. Okay. Now, this blue graph, you may notice, looks like a cosine wave. Looks like cosine, doesn't it? So in future college math classes, you may have to convert sine waves to cosine waves, and you would have to do this sort of thing. So basically, sine x plus pi over 2, it can convert this to cosine x. Okay, so same thing. This shifted to the left, this shifted to the right, but instead of a whole quadrant, it's just moving pi over 4. Okay, so write down the transformational. If you take sine x and change it to sine x minus c, basically the c is going to shift it left and right. When c is positive, it moves to the right. Now when I say positive, it's x minus the positive value here. Okay. Okay, so basically the thing I was trying to talk about is if you have sine of x plus pi over 2, that's going to give me a cosine graph. Okay, I don't think you're going to see that on this HL test, but it's something that you should be aware of. Now, I didn't intend to put a minus here, but let's talk about this. If I have sine minus pi over 2, sine minus pi over 2, okay, this also looks like a cosine that's flipped on reflected on the x-axis, doesn't it? So look at the blue one. We know cosine looks like this, but this is a cosine graph, but it's reflected on the x-axis. So this is a reflection. It's a cosine graph that is reflected on the x-axis. Okay, so we've realized that period can be found by pi over b, and the principal axis and some of these other ones are a little bit easier. But okay, let's talk about example 4. This is where you're going to use sinusoidal regression on your calculator. And you're going to be doing that for part H. Okay, so, but before we do that, state the principal axis. So to figure out the principal axis, you could take the y value here, 2 and negative 8. If I find halfway between 2 and negative 8, I guess 2 plus negative 8 is going to give me negative 6, and we divide that by 2. My principal axis is going to be at negative 3. Okay, hence find the value of d. D is -3. Okay, so uh, they're referring to y equals a sine b x minus c plus d. So d gives you the value of the principal axis. Okay. Now, find the amplitude. So the amplitude is the distance from the principal axis to the top. So if I know the principal axis is at -3, the distance between -3 and 2 is going to give me 5. Okay, and the distance from here to here is also 5. So this a value here is the amplitude, and the amplitude here is 5. Okay, now we need to figure out the period. So they've told you that we've got a coordinate at 1, 0, which is I put a dot there. And they also told me that the first minimum is 5, -8. And so when I look here, I'm back at the top. So here I'm at 1. I'm back at the top at 9, 2. So now I know that the period goes from 1 to 9. So the length from here to here is 8. My period is 8 units. So the period is 8 units. The distance from here to there. Okay. So if I know the period is 8 units, we know that I can say that the period is pi over b. I can also find the b value by 2 pi over the period. Okay. So using this relationship, I'm going to calculate b. We know the period is 8, so I can say 2 pi divided by 8, and then I'm going to get my b value is pi over 4. Okay, now we're almost done. We want to find the smallest value of c. So and how did we get 1? I forgot how we got 1. But it's 1. Okay, and this is a sine wave. Okay, so and for this question, example 4, you can use the handout that goes along with this, with the calculator steps here. Okay, and so now that we've got all these values here, we know our equation is y equals 5, because that's the amplitude, sine pi over 4, parentheses x plus 1 minus 3. Okay, and so now we're going to use sinusoidal regression. So I'm going to use, so we first of all, we have to figure out what x is at 0, and we have to figure out, so we know when x is 1, we're at 2. We know when x is 5, oh sorry, you can't see what I'm doing. We know when x is 1, we're at 2. We know when x is at 5, we're at -8. We know when x is at 9, we're back at 2. So we need to figure out these here. So given this equation that we've figured out, if I plug in 0, I've got 5 sine pi over 4 times 0 plus 1, and then minus 3. So what we have here, I'm going to type this in, 5 sine pi divided by 4, close parentheses, minus 3. And we get 0.53553. Okay. And at 8, we're going to be at the same height as we are at 1. Okay. So, okay, so now I'm going to follow the instructions because we're trying to use sinusoidal regression calculation to give the same result. So using sinusoidal regression, we're going to follow these steps. So you're going to hit Stat, and then go over to Edit, and then hit Enter. So that's what I'm going to do. I'm going to hit Stat. It's at Edit. I'm going to hit Enter. And now I'm going to type in the numbers. So we know when x is 0, we've got 0.53553. When x is 1, 5, 8, and 9, 0.5, 5, 3, 5, 5, 3. We're going to at 1, 2, negative 8, 0.53553, and at 9, we're at 2. Okay, so we type these into list 1 and list 2. And I didn't actually type in this number. I typed in the equation 5 sine pi divided by 2 minus 3 when I was in this space, and that gave it more exact. So let's see where I am right here in list 2. What I did was I typed in 5 sine pi divided by 4, close parentheses, minus 3, and then I got the exact answer. Notice how the decimal goes way, 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 way down. Right? Okay, so now we're going to hit Stat, arrow over to Calc, Stat, arrow over to Calc, and then we're going to find C sine regression. Okay, and then hit Enter. So I can go all the way down. I can also go up, and then there. See sine regression. I hit Enter, and then we type in L1 and L2. Now it shows this screen here. I have an older calculator, it doesn't show that, but to get L1 I can do second 1, and then comma, let me zoom out, comma, and then second 2 to get L2, and I hit Enter. And now it gives me these values here. Y equals A sine BX plus C plus D. And we have these values all here. And notice these are the same thing that you see here. Okay. And so if I needed an equation, I can do this. And this works even if I got weird decimals. And you could also note that this right here, if I do pi divided by 4, I'm going to get that here. And so, and note the equations are the same. F of x equals 5 sine pi over 4x plus pi over 4 minus 3. Or if I was writing it in that other format, I would be sine pi over 4x plus 1 minus 3. Okay. All right, let's finish this handout. Okay. So, we've got this equation. Sorry. Okay, so we know my amplitude is 2. Principal axis is -5. My b value is 3, so the period is going to be 2 pi over 3, and the phase shift is 4. Okay. I'll let you hit pause and check your answers. Okay, I'm going to lift this up. You can hit pause and check your answers. Okay. Same thing. You can hit pause and check your answers. And here you go. Hit pause and check your answers. I hope this was helpful, and good luck with the assignment.